Oopsie. All right. I know it's hard to focus, end of the day on a Friday and everything that's going on, okay? But let's kind of, I do want to go through this with you guys because there is a couple important pieces, okay, that are important that I feel like you might need me for, okay? So I want to make sure I'm there for you. But before we do that, let's just quickly, again, yesterday I introduced you to the binomial theorem. Are we feeling pretty confident just working with it with our basic questions? Right, so our binomial theorem, you guys should have had your practice. Just if I gave you what term you're trying to find, I give you the binomial, you can put your n, your k, your x, and your y in, right? That's what we focused on yesterday. So we're still going to do some of that today, a lot of it today, except the information you're given might look a little different, okay? So for this first one, it says one term in the expansion of 3x plus by all to the exponent of 4, where b is greater than 0, is 216 x squared y squared. Determine the value of b. Okay, so is this a little bit different than last class? Yeah, so here I'm actually giving you the term. So does that mean I'm actually giving you this side of the equation? Yeah, so I know that side. So I know that that piece is going in there. Okay. Do you still know what n is? Right, what is n? 4, so that's fine. Do I still know what x is? X is still, in this situation, x will equal 3x. And y will be dy, okay? But what is the piece that I'm missing? K, okay? Some of them you'll be able to just look at it and know what k is. Can anybody tell what k is in this situation? Okay, so no. 3, 4, so are we confident? Anybody confident they know what k is? Without doing any math in your head. Without doing any math in your head, you can just see it?
I know. Yeah.
Okay, so how are you doing it without any math in your head?
The y exponent value?
Okay, so the y exponent value, okay, listen up guys. Why is the y exponent value k in this instance? That's just a coincidence. Right, so if you guys were just going, k is here, so that must be that k is 2. Yeah, no, that's just it ends up being 2, but that's just a coincidence. Okay? Yeah? Emma?
Still math. With really simple math, you just do the exponent on brackets minus the exponent on y. So minus 2.
So you're saying the exponent on the what?
The exponent on the brackets minus the exponent on the y.
Yeah, no, that's just a coincidence.
Because 0, 1, 2 is the third term, and then k is always in the next one.
So you're using the pattern, which is one of the methods we can do to figure this out, okay? So guys, have I shown you, so to me, you have to do some math. You can't just look at it and go, yay, it's this, okay? There is a little process to this, okay? So one of the processes is what Sean was just saying. Can we do the pattern? This one's a quick pattern. So if you could do this pattern in your head, then you could get the answer quite quickly, okay? But to me, I'm going to write it down. I don't want us to do it in our head, just because do you think the pattern's going to get more complicated? Because remember yesterday, did I do more complicated patterns already with you? So to me, I showed you a little bit of patterning last class. I'm going to show you how to use the formula as well, okay? And again, this one's an easy one to see. So start with easy. So if we do pattern, okay, so if we follow the pattern from what we learned yesterday, okay. So again, do I care about anything about the coefficients when I'm doing? No. I just want to figure out where x squared, y squared is going to happen. So with patterning, right, first term has a what in it? X, right? So x, and we know that first term is going to be to the exponent of 4. The second term has a what in it? A y. So the second one has a y, right? And then it's going to be to the exponent of 0. So that's where it always starts. So the first term is always going to be to n, okay? And the second term is always going to be to 0. Do you guys agree? And again, will that change a little bit if there's exponents inside the bracket on the x and y? That will also be in here. So remember, if it was, say, a 3x squared, then the first pattern would be a x squared to the power of 4. If there was a degree 2 inside there. We'll do some of those in a minute. So basically what I'm doing is this is going to be what term 1 would have. So term 1 is going to have an x to the power of 4. Right? Because y to the power of 0 is gone. Okay. Term 2, the x now becomes a what on it? What degree is going to be on the x now? A 3. The y will now have a 1. So term 2 is going to be an x to the power of 3, y to the power of 1. Do you guys already see the pattern now? Right? So the next one will have an x squared, and then y to the power of 2. So x squared, y squared. Can I stop? So patterning will show you the term number. But as soon as you see the term number, can you guys find k? Yes. So the pattern showed us that term 3 is going to have the x squared, y squared on it. So therefore, you can know that k equals to 2. Okay. So this will be the difference. So if you use patterning, you'll know the term number, that it will tell you the term number, which then will allow you to find k. If we use the formula, it will actually solve you for k. So I'm going to show you the formula now. So do you guys agree that that was an easy pattern? Yes, yes. Okay, so now if I use the formula, which I didn't show you guys yesterday. Okay, so formula. So if I use the formula to solve, this is the part of the formula. I'm just going to write it down and then I'll show you how to substitute the numbers in. So the part of the formula that helps us figure out, right, the variable piece is x n minus k y to the power of k. Do you guys agree that that is the piece of the formula that helps me figure out all the variable stuff? Yes, yes? Okay. So what is in place of x in the brackets? Right? So again, do I care about the coefficient though? No. So it's just a x all to the power of, do I know what n is? Right? What is, yeah, exactly. So 4 minus k, and then y is still, because again, I don't care about the coefficient, I'm ignoring the coefficients. Okay? They don't help me with my variable piece of my terms. Okay? So then the next piece is times y to the power of what? K. And do we know what this should equal? This should equal x squared, y squared. So by using the formula, you're basically making statements that you can solve. Okay? So what this tells you, this tells you two things. It should tell you that x, I don't want blue, that blue. Sorry. This should tell you, therefore, x to the exponent of 4 minus k should equal what? X squared. Do you guys agree with that statement? It also is telling me that y to the power of k should equal y squared. Do I have two bases? Right, so these two bases right here, x to the exponent of 4 minus k equals x to the exponent of 2. Since those bases are the same, can I logically say that 4 minus k should equal 2? K equals 2. Should I solve the other one though? Is that easier to solve? All right, the second one, y to the exponent of k equals y to the exponent of 2. So logically, if this is a true statement, k is equal to 2. You didn't have to solve both of them, just solve one of them. Okay. Should they solve to the same? Yes. So that's using the formula. So again, if you use the formula, it literally solves for k. Okay? If you use patterning, you'll get to the term number, which then you'll be allowed to get k. Does that make sense, the difference between the two of them? And again, I don't care. I just need you guys to tell me what k is. Okay? So worst case scenario, you had a brain fart and you cannot for the life of you figure out what k is. Could you still get the question right? Yeah, because technically, could you just use the binomial theorem and put 1 in for k, 2 in for k, 3 in for k until you got the term that got an x squared, y squared? Yeah, that would be the worst, miserable kind of idea to do it. But you could, okay? Because like I said, if you can't get k, the worst case scenario you would use, if you were having a really, really bad day and you had to use up all your chances, the most you would have to use it is 5 times. You guys agree? Because this only has 5 terms. Okay, worst case scenario, you use the binomial theorem 5 times, and you finally get the term that has an x squared, y squared. Okay, that is not what I would hope you would have to do, but that is the worst case scenario. So now we have everything we need, right? So now we can use our formula. So using our formula, so I'm going to do baby steps again. So term, so again, what was k? 2 plus 1, and I know I'm going to change that because do I actually know what term 3 is? So I'll replace that in my second step, even though could you replace it right away in your first step? I just want to show all my work, okay? So equals n, what was the exponent again? 4. So bless you. So 4, choose 2, x again was 3x. So I'm doing my substitutions, right? And then n again is 4 minus k, which was 2, times my second term, which is a by, all to the exponent of k, which is 2. All right, so then term 3 we know is, so I can replace that by 216 x squared y squared equals, did anybody type in 4 choose 2? Good. So 6, and then 3x, and then 4 minus 2 is 2, so 3x all squared is 9x squared. Now, am I okay? Yes, so not okay. Do you think that's a common mistake students do? Right, because again, it's by times by, right? So then I put the squared on the y, but I did not put the square on the 2. Okay? So make sure it goes on both. All right, so then from here, we can solve this. So we have 216 x squared y squared equals 54 x squared y squared b squared. Can we divide that whole 54 x squared y squared off? Because we're solving for b, so we're isolating b. So then we have 216 x squared y squared divided by 54 x squared y squared equals b squared. Now 216 divided by 54, 4. And then the x squared y squareds divide out. So then we have 4 equals b squared. And then what do we do to both sides? Square root. Now, normally, I would say b equals plus or minus 2. But did I get more instructions in the above? Well, first of all, pretend we didn't read the instructions. We were just solving. Do you guys agree that I do have two answers without any other instructions? Okay. Do we always forget the plus or minus sometimes? Yes, let's not be that, right? So there is plus or minus, but this one did give us more instructions. So if we go back up here, it did say that b had to be greater than 0. Right? So since it gave us those instructions, then you would just finalize it with b equals 2. Oh my Lord. Right, and then that would be done. So again, does it make sense you could have two answers in an expansion? Because remember with binomials, a lot of times if we have a minus, minus times a minus still is a positive, plus times a plus is still a positive. So it makes sense that two possible answers could go in there and still get that term. But because of that, we only picked the one of them. All right. So here, a little bit different again. So here it says given 2x to the power 4 minus y, all to the power of 12. Right, so there's my binomial. One term in the expansion can be written in the form of ax to the exponent of m times y to the exponent of 4. The value of m is, and the value of a is. Okay, so we can't get a without using the entire formula. Okay, but we can't use the entire formula until we know what term number, right, that will have a y to the power 4 on it. Because do I know what x is going to have on it yet? No. So can we still do our pattern? Yeah. So, or the formula. So again, I'm going to keep showing you guys both so you get comfortable with both. So this one's a little bit different of a pattern, even though is the y pattern super easy? So do you guys see now, can you tell which one's going to have a y to the power of 4? What term is it going to be? Term 5. So if you knew that, you could just continue on. But even though that you know that it's going to be term 5, does that help you with the m? No. So you still need to see, because does that mean the x is going to have a 5 on it? Like, or is it like the, how do I say this? That's going to make sense, right? You know that y starts at 0, right? And it's 1, 2, 3, 4. So that is why it's going to be term 5 and not 4, because it starts at a 0. But that doesn't help you with a. Okay, right, or sorry, doesn't help you with m. So let's do our pattern. Because x has a different number on it, right? So it's not as easy for x. So here we go. So let's do our little pattern. All right, so right now, what is in the first position? X to the power of 4. Do you guys agree that that's my first term? I don't care about the coefficient, ignoring that. But is my first term an x to the power 4? So therefore, that is all going to be to the exponent of 12. My second term, I don't care about the minus. The minus y doesn't matter. What is the base? The base is a y. And right now, it is not that I need to write it, but you guys need to picture. It does have an exponent of 1 on it on the inside, but it gets raised to the power of 0. So this is going to give me x to the 48. Because it's going to be y to the power of 0, but y to the power of 0 is just a 1, right? So 1 times x to the 48 is still x to the 48, right? So this is my term 1. So term 2, and you wouldn't have to continue this work as soon as you see the pattern, right? So this will be x to the 4, all to the power of 11. This is y to the power of 1 to the exponent of 1. So x to the power of 44, y to the power of 1. I usually do 3 terms just to confirm my suspicions. Okay, because right now it looks like x is going down by what? 4, and y is going up by 1s. Right, and if you are know beyond a reasonable doubt that that is what's happening. Can I just write all my terms now if I wanted to? Just following the pattern? Absolutely. That's what I would expect you to do. But I always do 3, just to confirm what I think I already know. Right, so then x to the 40, y to the 2. So then term 4 is going to be x to the what? Because x is now, all the degrees are going down by 4, yes? So 40 minus 4 is 36, and y's are going up by 1s. So the next one will be x to the 32, y to the 4. Can I stop? Yes. So what we just figured out with the pattern, right, it is term 5. Right, so since it's term 5, I know that k equals 4. And we also know that m equals 32. So I know the first piece. So I'm still going to show you guys the formula. Right, so if you chose to use the formula to solve for m, usually the formula students find more complicated, right? But I like both. Okay. All right, so if we use the formula, again, you're picturing, right, you're picturing this part of the formula, x n minus k and y, come on, y to the power of k. That's the part of the formula we're using. So what is my base without the coefficient in the beginning of the bracket? To the power of 4. So I have x to the power of 4, right? That's the piece that is going to help me figure out the variable piece of my term. But this is now raised to the what? N minus k, right? So what's n again? 12. And k I don't know, so that stays a k. Right? Times, what's the base? Don't care about the positive, negative. So what's the base with the exponent in the second term? It's just a y. Right now it has a 1 on it, but then it's being times by k. So can I just say k up here? 1 times k is just k. And this must equal x to the power of m, y to the power of 4. So this one's super fast. Do you guys agree that k equals 4? So then I can use that to solve this equation. Right? Because do you agree that the exponents on the x's have 2 variables in them? Right? So right now I can't solve for m quite yet. So right now you know this for sure. You know that 4 times 12 minus k should equal m. And you also know from the yellow k equals 4. That's what you learned from using the formula. So therefore you can go 4 times 12 minus what? Do I know what k is now? Yeah, so 12 minus 4 equals m, 4 times 8. So therefore m equals 32. And the reason, guys, I keep showing both is the diploma does weird things sometimes. They'll like sometimes go little Johnny solved for k, and they might use a form of patterning, right? So then you're going to have to follow little Johnny's work and find his mistake. Or little Johnny might solve it using the formula, right? And you have to find his mistake. So you have to be familiar with both for me to be happy and confident that nothing will mess you up. Okay? You won't get stuck, either one. But on a quiz, I'm not going to tell you which one to use. I just need you guys to be able to get your A, and to be able to get your coefficient, you have to have K. Okay. All right, so then from there, You guys go ahead, put it into your formula to get your coefficient. Because you have everything now, right? To be able to find a coefficient, you need k, you need n, you need x, you need y. And we have all that, so away you go. And then look up when you're done. Did you guys punch it in already? What does 12 choose for? $4.95. Thank you. I'm being lazy. So 2, 4, 8, 16, 32, 64. Thank you. So 256. X to the power of 32, and then negative times negative times negative times negative is a positive, y4. $126,720. Thank you, Emma. Very much. Right, so these questions, just more work you have to do before you hit the formula, right? Because yesterday you're always given k, you're always given n, you're always given x and y. So here you got to work for it, okay, a little bit more. But once you have all the information, then you're back to just using the formula like normal. So I'm going to do a couple more with you. This one you're going to do, but I just want to read something first just so you guys don't get confused with the wording. Okay, so this one just says, in the expansion of x plus root 5 all to the exponent of 9, written in descending powers of x, the coefficient of the sixth term to the nearest whole number is. For here, do you guys agree the first term has an x in it? So when you expand this, would x not be in descending order? Do you guys agree that x would, or not agree? Would x go in descending order if you expanded this? Yeah, it would. So don't freak out that this means anything, okay? Because again, if x was the second term and y was the first term, then that's basically saying it's backwards. I haven't seen them do that before. So don't freak out about that sentence. It's going to be written in descending powers of x. That's what the binomial theorem always does. First term is where x is high and the second term is low, right? Second term is x goes down, y goes up. So it automatically does that for you. So technically, even though it's a root 5 inside, that shouldn't matter. Is this just what we did yesterday? Yes, no? Yes. So all I'm going to do for this, you guys will do it later, is just write our information down. What's n? N is 9. What's k? 5. Good, because it wants the sixth term. So since it wants the sixth term, k is always one less than term number. And then we know that x is just going to equal x. And y is going to equal root 5. So you guys do that later. But what I want you actually to do when you go back and do this later, it does tell you to round your coefficient to the nearest whole number. Does it make sense that your coefficient is going to be irrational? Yes. So what I want you to do, just to challenge you a tiny bit, I want you to write your coefficient as an exact value simplified first. Make sense? then type it into your calculator and get the decimal. So do that later though. You'll have time. And then I'll do it as well, and then you guys can see if we agree. All right, so I do want to do a couple more that get a little bit more complicated. So here it says in the expansion of that, okay, written in descending powers of y, the coefficient on the y to the 8th term is. So again, worst case scenario, if you had no idea how to figure out k, you would use the binomial theorem how many times to still get the question correct? You're having the worst day of your life. 6 times is how many times you'd have to use it, okay? But you would hopefully get it before you trying all of them, okay? So let's do our pattern. Okay, so if we do our pattern to figure out where y8 is going to be, right? So again, my first term is a what? Not yet. First term, y. What does the first term have on it, guys? y3. This is being to the exponent of 5 times, what does my second term have? Right, y. What is that sound? Stop it. I feel like, is it singing? Is it what? All right. Oh, it's humming. That's got it. All right, so do you guys agree? Second term, y to the negative 4? So that is all getting raised to the power of what? 0. Because again, first term starts at n, second term starts at 0 every time. And then you work your way down. So term 1 is going to have a y to the 15. Because again, negative 4 times 0 is y to the 0. That's just a 1. So that second piece basically is gone. So then, talk to me, guys, if this pattern is not making sense. All right, so then my second one still is y3. That's never changing. That's what's inside. But the n is going down by 1. Right, so then this will be now to the exponent of 4. Inside again stays the same. That can't change. But my outside exponent goes up by 1. So I'm going to say it out loud, but I'm not writing another step. So I have a y to the 12 times y to the exponent of negative 4. Using our exponent laws, that's going to give me y to the exponent of 8. Good. Can I stop? Yep. So then I know term 2 is the winner. Therefore, k equals 1. And remember, if I needed to keep going, you can already see the pattern. You know that the pattern's going down by 7. So you could just, instead of writing all the work, you go term 3, term 4 until you hit the appropriate one. And we know in total there's only 6 total, so that's where you would stop. There would only be 6 terms that you would write down. So if you never hit that pattern, right, then either you did something wrong or there's a typo. Okay. All right, so using the formula, right, so using the formula, I'm just going to make this bigger. So again, you're picturing x to the n minus k, y to the k. That's the part of the formula we're using. So again, in the k position, don't care about the coefficient, right? So the first term is y to the power of 3. And that is raised to the n minus k. So what is n again? 5 minus k times the second part of that formula is what's in the second position. So the second term, ignoring the coefficient. So in the second term, I have a y to the negative 4, but that has to be times by k. And I need this to equal y to the 8. This one I'm going to have you sink in for a minute. Does that make sense? Because do you guys agree that if you did use the entire formula, you would have actually put in here, like where the y3 is. Well, never mind, there's no coefficients. Right? But if normally if there was a 2 here, like a 2y cubed, do you guys agree that this would have been a 2y cubed if you're using the entire formula? And then it would have been to the n minus k. We don't care about coefficients because we're just trying to find the pattern of the variable, so we get to ignore the coefficients. So that n minus k affects the variables. It's just with this pattern, sorry, I just want to show you guys something, right? The formula has more algebra, right? There's way more room for error with the formula, but I just want to show you guys, right here, it had a degree 4, so that had to go there times the n minus k. If there's a degree 1 there, it's just easier, but these ones don't have degree 1s on our bases of y. Right, so then here, you thought you didn't like this. We can't just drop the y's. You have to watch and see if you guys can follow. I'm not going to say anything. I'm going to go slow and see what you guys do. I'm like, it won't erase. I'm going to erase it. That's too tight. Yeah, you're stopped. Oh, yeah, you confused me already. Yeah, no. Okay, let's try this again. What do you mean, why? That shouldn't be the confusing part. Just because some people don't get the pattern. I don't know why. Like, it is just a thing. It's funny because I will have students do both, right? It's just like anything. Do you think some people are going to like the formula? So I bet some of you will. I actually like the formula because I like algebra. Like, the algebra doesn't scare me. But I will let you know, the formula, there's always more errors using the formula. Okay? But the thing is, guys, if you solve for k wrong, are you going to find out when you use it in the formula? Yeah, because if you get the wrong k value, when you use the formula, you're going to get a y8? No, so then you go back to the drawing board. Okay? So you will catch your mistake, right? So, but again, you think you didn't like it, it's going to get not worse, but you'll be like, oh, because right now, you can't just drop the y's and solve for the variables. Why? Because well, what you didn't work though. So what did you do in between? So you actually didn't. You did an operation. So Rona said, I did, but she did it correctly because you can't just drop the bases right now, guys. What you have to do is, since you have two bases the same, go back to your exponent laws. If you have two bases the same, it's multiplication. What do you do to your exponents? You add them. So as long as you do that, then yes, you can drop your bases. Okay, so what I mean by that, this is the same as, I know you're going to not like the plus minus, but I just want you to see, I did add them. Okay. Would you agree with that statement? Using your exponent laws, same base, you can add your exponents. Now you can logically drop your bases. Okay? So if you choose to drop your bases in this step here, the one before, and you add your exponents, you actually just did it in one step instead of write this step down. I'm okay with that. Okay? But you can't logically say they're equal to each other until you have one base on one side that's the same as the other base on the other side. Right? So you are using exponent laws to be able to drop it and not write this extra step. So now we can say 15 minus 7k equals 8. Minus 7k equals negative 7. K equals 1. All right, so bring the 15 over, it becomes a negative. Divide both sides by negative 7. K equals 1. Okay. So to save time, guys, the biggest thing I'm teaching you guys today is to get K. So you guys can go and actually find, because you guys agree that once I have k, we're good, we're golden. So you guys can figure out what the coefficient is later, after I do a couple more with you, because the pattern and the formula, they will get a tiny bit more complicated, but not really. Okay? So I'm going to do one more with you. And then, like I said, you'll go back and finish this one. I will go back and finish this one, just like that other example. You'll go back and finish. All right, so here, this one we talked about yesterday. Okay, so here it says given x minus 5 over x squared, all to the exponent of 12. What term number is the constant term? So again, the constant term, we're so used to having it at the end, right? But can everybody see that this one will not have one at the 13th term, right? Because there's an x on the top and there's an x on the bottom. So somehow they have to get closer and closer and closer, so they divide out. So that constant term has to be somewhere in the middle, okay? So again, I will show you how to do the pattern to figure out, because what were we trying to find? An x to the power of what? 0, right? Because what is x to the power of 0? 1. So that's the pattern we're trying to find, is the x to the power of 0. Okay, so let's do, and again, do not care about the coefficients. So what's in the first term in the binomial? Just has a what? An x, right, to the power of 1 on it. I don't have to write to the exponent 1, but this is all going to go to the exponent of what? 12. Times, what does the second one have? So what am I writing? I'm writing a 1? Okay, you're going to do it this way. 1 what? You guys tell me what to write. 1 over x squared? Do you guys agree with that? I don't want to do that, but I agree with you. Can I just go x negative 2? If you want to leave it as x, 1 over x squared, it'll work. But I like having everything on the same line. So you guys do you. If you like it that way, I'm going to do me and change it to an x negative 2. Is everybody though okay ignoring the 5? Because what does the 5 have to do with? The 5 deals with the coefficient. I don't care about the coefficient right now. So I'm ignoring the 5, it's a 1. So all I'm doing is bringing the x2 from the bottom. If I bring it to the top, it becomes a negative. And again, if you hate that, leave it as 1 over x squared. We'll get the same answer. But this whole thing is to the raised to the exponent of 0. Right? Because remember, first term starts at n, second term starts at 0. What's inside is what's inside the binomial. So this will just be x to the 12. So that's term 1. Because remember, it always goes in descending order of the first term. Right? And here they go together because they're the same variable. Term 2 is x to the power of what now? 11 times, inside stays, that's never changing. The outside now is a 1. So I have x to the 11, x to the negative 2, so that's going to be x to the, what, 9. Term 3, x to the 10 times x to the negative 2 to the power of 2. So I have x10 times x negative 4, which is x6. Can we stop now, or are we confident with the pattern? They are going down by 3. So therefore, x4 is x3. Term 5 is x0. So there's our winner. Right, so our constant term is term 5. So therefore, k equals 4. Oh, never mind. This one's asking for what? What term number? Never mind. We don't even need k. Right, so the constant term is term 5. So not our k value. So I know you might not like it. But guess what I'm doing next? The formula. All right, so again, the formula I'm using, this part of the formula, I'm just going to keep writing it down. Right, that part of the formula tells me my pattern on my variables. So again, in my x position, I'm just replacing it with an x. Do you guys agree? Because that's all that's there. And then n is 12 minus k. And what's in my y position? Right, x to the negative 2, or if you prefer, 1 over x squared. That's what you could also write. All to the power of k. And then this, you would have to make the connection, because this one is not telling you what it equals to specifically. It is saying it's the constant term, so you have to make that connection that that is x to the power of 0. Okay. So then I have x to the 12 minus k times x to the negative 2k equals x to the 0. So what do I do to the exponents on the left? I add them. Right? So I add those exponents. So then this is the same as x to the 12 minus 3k equals x to the 0. Now I can set my exponents equal to each other. Right? And like I said, if you set your exponents equal to in the above step and just plus them, right, it's the same thing. So now I have 12 minus 3k equals 0. 12 equals 3k. K equals 4. So again, that wouldn't be your answer though. So since k is 4, therefore it's term 5. Because you have to go 4 plus 1 equals 5 from your formula. So a little bit to think about, guys, today. Do you guys agree that I'm making you think a little bit harder than I did yesterday? Okay. So what I want you guys to do is see if you can get your term or your k for this. Okay, so this one's saying you want the x squared term. Do you guys agree the pattern's a tiny bit more complicated when you have fractions and variables on the bottom? This they would consider a standards of excellence question. As soon as the binomial, right, ends up having variables on top and bottom, and you don't have k, they say that that's the hardest question. That's the standards of excellence, which I agree, right? It does make you work way harder than when I just say find term 7. Well, this one wouldn't have a term 7. Find term 3. So you guys, I'm going to shut this off. I'm going to turn it back on, but you guys do whichever process you want to do. I'm going to do both, and I'll turn it back on in a minute. See if you can get k. Using which one you think you like more. What'd you guys get for K? Everybody get 2? Not, people aren't quite finished yet? You still have to get the coefficient, but you can't get the coefficient until you get K. So if you can get to 24x squared, you've done the hardest one, type 1 I can give you. Okay. So please, 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 well, before that, we make sure that if you're not good during work time, put up your hand. I'll come sit with you. But it is important, like I said, that you can get K with if I don't give it to you, whether through a pattern or a formula. So please make sure, guys, these are the ones that are not as straightforward as the ones you guys did yesterday, but please go back and finish the ones that I skipped. So go ahead and back and finish the coefficient for this one and go ahead and do this entire question, right? So that's another warm-up for you. But again, leave it as exact, then round.